All right, now, so we're going to go through lesson 12. So you find a brass bottle that looks really old. When you rub some dirt off of the bottle, a genie appears. The genie offers you a reward. You must choose one, 50,000 or a magical $1 coin. The coin will turn into 2 coins on the first day. The 2 coins will turn into 4 coins on the second day. The 4 coins will double to 8 coins on the third day. The genie explains the doubling will continue for 28 days. Okay, so we need to figure out how many coins we would have after 28 days. And they are all, remember, each worth $1. All right, so the number of coins on the third day will be 2 times 2 times 2. Write an equivalent expression using exponents. So we know that exponents are the little number right at the right-hand corner of our whole number. So 2 to the third represents 2 times 2 times 2. Okay, so this would be an equivalent expression. Okay, and so that would tell us 2 times 2 times 2. Well, 2 times 2 is 4, 4 times 2. We have 8 coins at the end of the third day. Okay, for number 2, what do 2 to the 5th and 2 to the 6th represent? Well, in this situation, evaluate 2 to the 5th and 2 to the 6th. So evaluate means we want to solve it without a calculator. Pause for discussion. Okay, so what that's telling us is 2 to the 5th. This is telling us how many coins we have on the 5th day. This is telling us how many coins we have on the 6th day. Okay, so 2 to the 5th would be 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32 coins. Okay, and remember they're worth $1. So that means we'd have $32 on the 5th day. The next one, well, we know that the first 5 multiplied together would be 32. So then 32 times 2 more would be 64 coins, which would represent $64. How many days would it take for the number of magical coins to exceed 50,000? Okay, so we've got to think about this. Think about how many 2s it would take us. So we're doing 28 days. So let's go ahead and see 2 to the 14th power. Okay, so that means 2 multiplied itself 14 times. Okay, so if we were to multiply that out, we would get 16,384. Okay, that's not over the 50,000 yet. Okay, so let's say 2 to the 20th. Okay, so 2, whoa, so that one actually comes out to be 1,048,576. So that's way over 50,000. So we need to go in between, somewhere between 14 and 20. So let's do 2 to the 17th. So 2 to the 17th power is 131,000. So that is still very large, but we're getting closer. So now we know it has to be between 14 and 17. So let's try 2 to the 16th. So 65,536. And just to make sure, we want to try 2 to the 15th to make sure that doesn't go over. So 2 to the 15th is 32,768. So we know that after the 16th day, we will exceed 50,000. Okay. Will the value of the magical coin exceed $1 million within the 28 days? All right, well, we know at the 20th day it was already over $1 million, so it's definitely going to be exceeding it. So let's see what we get for 2 to the 28th power. We actually end up getting 26,840,000 Actually, it's going to be 268,435,456. So we very much so exceed a million within that 28 days. So just to rewrite this, just so it got everything lined up, 435,456. So 268,435,456. So if I were you and I knew how to do math, I would have chose the magical coin, because it is going to way exceed 50,000. But not knowing how to do the math, you would have probably chosen 50,000, because you would have thought, well, how could it be more than 50,000 in 28 days? But the way that we were doubling and with our exponents, and because we knew how to do math, we found out it would be this much money. So if you ever run into a genie, I would choose, make sure that you weigh both options before choosing an answer. All right, so 12.3. Continuing with exponents, we've got make 81. Here are some expressions, all but one of them equals 16. Find the one that is not equal to 16. Okay, so 2 to the third, remember, is 2 times 2 times 2, and then times 2 for the last one. So 2 times 2 is 8. 8 times 2 is, or 2 times 2 is 4, sorry. 8 times 2, 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So it's not this one. We know that 4 times 4 is 16. 2 to the fifth divided by 2. So that means first we need to find out what 2 to the fifth is. So let's see. We've got 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. So then we've got to divide 2 divided by 32. That is 16. So it's not this one. 8 times 8, because remember, this is not 8 times 2, it's 8 times itself twice. This is 64. So this one is the one that is not equal to 16. Write 3 expressions containing exponents that each expression equals 81. 81, so we know that 9 times 9 is equal to 81. Okay, so to make that contain an exponent, we can say 9 to the second power, okay? But then we could also figure out, well, how many 3's are in 81? Because we know that it takes 2 3's to make 9, and if there's 2 9's, that means it would take 4 3's to make 81. So if we did 3 times 3, we'd get 9. 9 times 3 is 27. 27 times 3 is 81. So this is our second one we could have made. And one more. So let's think of, well, we could have said, kind of like what they did up here, we knew that we could have said 3 to the third, that's 3 3's, times another 3 would also give us 81. Okay, there's a couple of ways we could have changed it up. We could have said 9 times 3 to the second power, because we know that that's also equal to 9. Okay, and remember the little dots indicate multiplication. All right, so now I want you to try your Lesson 12 practice problems and see what you can do on your own from what we've learned previously on exponents and what we've talked about today.